All right, guys, we are now going to talk about rule number 2. We've already talked about rule number 1 for reducing radicals. Now we're going to go look at rule number 2 that says no radicals in the denominator. Now, what I want you to do, you should get your notes key that already has this worked out, but I'm going to explain what does all of that mean. Okay, so we're going to look at number 5, and when we say no radicals in the denominator, yes, we are going to be dealing with fractions. So, guys, for the rest of the year, get ready. We're going to have fractions. So we got to make sure that there's no radicals in the denominator. So we are going to do what is called rationalizing the denominator. Okay, where you're going to rationalize the denominator, if I can spell, and I'm writing it over here off to the side. Okay, we are going to rationalize the denominator. That's what this is called. So on number 5 right here, okay, to rationalize it, it means that I'm going to get rid of the square root in the denominator. Well, how do I get rid of a square root? Well, I square it. So what I'm going to do is I'm going to multiply both the denominator and the numerator by whatever is underneath this square root. So I'm going to multiply it by itself. Now, when I take the square root of 5 times the square root of 5, okay, well, guys, let's see. The square root of 5 times the square root of 5, isn't that the square root of 25, right? Because I can multiply radical to radical. So 5 times 5 is 25. Now, up in the numerator, I've got a whole number and a radical. Well, I can't do 3 times 5. I can only multiply whole number to whole number and radical to radical. So this just ends up being 3 square root 5. Now, that is not simplified because I can take and get rid, there's a perfect square. There's rule number 1, no perfect squares in the radicand. Well, the square root of, 25 is 5. Okay, and then I bring down 3 over square root of 5, and then I'm going to ask myself again, can I simplify any more? Well, what do you guys think? Can I simplify 3 square root 5 over 5? Yes or no? Okay, so let's see how you did. The answer is no, because I can only reduce whole number to whole number. Radical to radical. There's no other radical. So if I cover up the radical, guys, you cannot reduce 3 over 5. That's as simple as it gets. You cannot reduce when you have a radical and a whole number. Those things do not reduce. That's like combining apples and onions. Guys, don't do it. That would taste really gross. Okay? So whole number, radical to radical. There is your answer in reduced radical form. Okay, so let me explain number 6, because number 6 is a little bit different. Okay, so let's look at number 6. Okay, now on your notes key, it says that 21 over 14 all of a sudden goes down to the square root of 3 over the square root of 2. Well, how did that get there? That is because I can reduce radical over radical. I can reduce this. So 7 evenly divides into 21 and 14. That is how come I can reduce those. Radical to radical, right? Apples to apples, if you will. Okay, now that I have reduced those or simplified, now I'm going to get rid of the square root. I'm going to rationalize the denominator by multiplying both the numerator and the denominator by the square root of 2. Now, the square root of 2 times the square root of 2. Well, guys, isn't that the square root of 4, right? Well, then the square root of 4 equals 2, doesn't it? Okay, the square root of 4 equals 2. Now, up on top, okay, up on top. Well, right here, square root of 3 times the square root of 2. I can multiply those because it's radical to radical. So 3 times 2 is 6. And right here, this is as simple as I can get it because the square root of 6 does not have any perfect squares in it. Okay. All right, so now I'm going to move down to one that's a little bit different. Okay, let's look at number 7, and I'm going to explain number 7 to you guys. Okay, on number 7, okay, if you guys see on your notes, the whole numbers, whole number to whole number, had already been reduced. Okay, so 3 goes into 3 one time, and 3 goes into 18 6 times. So now I'm looking at 6 square root 2. That's what it reduces down to. Okay, so now I've simplified it, but I've got to rationalize the denominator. I need to get rid of that square root of 2 in the denominator. And what do I need to do to get rid of that square root of 2 in the denominator? What steps should I do next? Okay, so most of you should be looking at your notes and you're going to say you multiply both by the square root of 2. You multiply the denominator and the numerator by the square root of 2. And when I do that, okay, I've got whole number radical, so I do 6 square root 2, okay, and then the square root of 2 times the square root of 2, well, guys, again, that's the square root of 4, which is 2. Now, I'm not done. I need to ask myself, can I simplify this anymore? Okay, whole number to whole number, radical to radical. Well, we've got a whole number and a whole number, don't we? And 2 and 6, those reduce. Okay, so I'm going to reduce this even further. 2 goes into 2 once, 2 goes into 6 3 times. So I have 3 square root 2 over 1, which is the same as 3 square root 2. I cannot reduce the square root of 2 and the 2. Radical to whole number. Nope, that's apples and onions. That tastes gross. Don't do that. Okay, so can't do those. I can only do whole number to whole number. All right, now I have explained some of the problems to you from your notes that you've already had. Now I want you to go get your assignment and we're going to work out a problem on your assignment. All right, we are going to look at number 4 on your assignment. Okay, now number 4, if you guys notice right here, okay, we have a whole number over a radical. Okay, and remember, rule number 2 says we cannot have any radicals in the denominator. So we need to get rid of this radical. Okay, so I want to know, what step would you guys do first? Okay, so now, guys, you probably answered a couple of different things. Most of you probably said, oh, well, we're going to rationalize the denominator. We're going to multiply by the square root of 98. We're going to multiply both the top and the bottom by the square root of 98. Absolutely, you can do that first. I'm going to challenge you guys, though, before you do that, to make things easier on you. Hey, guys, let's see. Are there any perfect squares in here? Let's do rule number 1 first. Are there any perfect squares to 98? So I go and I look, okay, you guys got your square root table, okay, and let me get it, we'll put it over here to the side, okay, well, 98 is in between 81 and 100, okay, so I'm going to see, well, does 81 evenly divide into 98? Nope. Okay, does 64 evenly divide into 98? Nope. What about 49? Yes. Hey guys, 49 evenly divides into, okay, 98, 49 times 2. So I would do the square root of 49 times the square root of 2. And I can simplify this. Okay, so now I've got 14 over, the square root of 49 is 7, square root 2. Oh, okay, so now we're getting somewhere. That's a little bit easier to deal with. Okay, so let's go back and see. Can we simplify any further? Remember, we can do whole number to whole number, can't we? Oh, so I can simplify 14 over 7, right? So 7 goes into 7 once, goes into 14 twice. Oh, so that gives me, okay, and I'm going to come right here, okay, I end up having 2 over the square root of 2. Okay, now, guys, if you look, these are the exact same thing. One is just simplified. Okay, so now what can I do right here to get that square root of 2 out of the denominator? What do I need to do? All right, so hopefully you said we're going to rationalize the denominator. We are going to multiply both the numerator and the denominator by the square root of 2. So up above, we're going to have 2 square root of 2, because remember, you cannot combine apples and onions. You want to do whole number to whole number, radical to radical. So 2 times the square root of 2 over, and the square root of 2 times the square root of 2 is the square root of 4, which is 2. All right, I'm not done yet. Guys, you need to go back and ask yourself, can you simplify any further? And look, okay, whole number to whole number. Can you reduce 2 over 2? Sure enough, those cancel out, don't they? Now, I don't have another radical, so I'm just left with the square root of 2. And that is as simple as it gets. Okay, So first thing, okay, simplify. Okay, second thing, okay, no perfect squares in the radical. Okay, then the next thing you want to look and see, okay, get rid of, okay, any radicals in the denominator. Rationalize your denominator. Then after you rationalize the denominator, go back again. Can you simplify? Okay. All right. Next up, guys, you're going to go watch the video on rule number 3 of reducing radicals.